advantages to enterprise on an equal basis to firms of the other nation, and this includes government-sponsored R&D programs. It endorses that the concept that each nation's access to the market of the other nation should be substantially equivalent. The existence of a so-called high-tech agreement between the two countries and the creation of such a body as the High-Tech Working Group is an encouraging sign that Japan and the United States can make progress in reducing high technology trade frictions and in ensuring that international competition in high-tech takes place on a level playing field. However, two storm clouds have recently appeared on the horizon, indicating that protectionism and aggressive government targeting is alive and well. First of all, Japan recently eased regulation on its value-added networks, a system which permits different computers to communicate with each other over public or leased lines. That should open up a multi-billion-dollar market for U.S. companies which have already developed and marketed such networks in the United States. But there's a catch. The Japanese Ministry of Posts and Telecommunications has drafted a bill that would limit foreign ownership of these value-added networks to 20% or less. Such a measure would permit U.S. firms to enter the Japanese value-added network market only as minority partners in joint ventures, thus denying them the opportunity to take advantage of their technologically competitive edge they now hold in this area. Second, and of even greater concern, is that Japan's Ministry of International Trade and Industry, MITI, is considering draft legislation that would provide for the compulsory licensing of software in the following cases. 1, if it's in the public interest. 2, if one firm develops software which relies on another firm's software in order to be operational. And 3, if a software program has never been utilized by the originator. In my mind, this covers most software ever written. In such cases, MITI could require a firm to license another firm to produce its software. The effect of this legislation is a virtual license for the wholesale appropriation of software. The originator of the software could find himself competing against his own software sold at a lower price or through distribution channels which he had no control over. The proposed legislation would also give Japanese firms greater freedom to modify and then market a variation of software developed by another firm, thus eroding the level of protection currently enjoyed under copyright law. Software is, by the way, the least competitive segment of the Japanese computer industry, and you've got to admit that this is certainly a very direct way of coping with the problem. If either of these proposals were enacted, it would be a major blow to the credibility of public assertions by the government of Japan that its high technology markets are open and that it is not protecting targeted industries. The U.S. government has vigorously protested these proposals, and we hope the Japanese government has backed off from them. Well, the obvious question, do we need to formulate a massive and formal U.S. industrial policy in response to foreign government targeting? That kind of cure could be as dangerous and short-sighted as continuing to respond to the needs of high-tech industries with attitudes and policies formed in the historical context of traditional industries. A U.S. industrial policy would inevitably tend toward policies to subsidize and protect government-selected winners, words that Ed Zhao used this morning. Even assuming it were desirable to do so, it would be utterly impractical given the rapid developments in technology and the shortness of product life cycles. Instead of targeted subsidies and protection, we look to performance-based incentives which can enhance the competitiveness of any entity that chooses to take advantage of them. Innovation in technology comes from many sources: big guys and little guys, old pros and new kids on the block. The R&D tax credit is an outstanding example of an incentive that works. Enacted as part of the 1981 tax legislation, this incentive provides for a 25% tax credit for incremental R&D spending. It is available to any corporation, whether high-tech or low-tech, high-profit or low-profit, so long as it increases its R&D effort. The credit has been a major benefit to the high-technology sector. During the time the credit has been available, digital's R&D spending as a percentage of operating revenues has increased from under 8% to above 10%. This in a time of recession when profits were under significant pressure. The credit is due to expire in 1985. Because most companies plan their R&D spending in 3 to 5 year cycles, bills have been filed in both houses of Congress to make the credit permanent. Enactment of this legislation would be a positive step toward strengthening America's competitive stance in high tech. Digital also supports programs to increase cooperation between corporations and universities. We see universities as becoming an increasingly important source of new technology and innovation. The bills to make the R&D tax credit permanent also include features to stimulate expanded corporate research contracts with universities and increased corporate donations of equipment to universities for both scientific training and for research. Finally, we also support greater joint R&D efforts among corporations. The Semiconductor Research Cooperative and the Microelectronics and Computer Technology Corporation are two outstanding examples. There is a growing sentiment that clarification of the antitrust laws would encourage the formation of additional cooperative efforts. Reducing the treble damage clause or eliminating the treble damage clause would be of particular help. What is needed is a policy climate that encourages and facilitates the horizontal dissemination of fundamental knowledge for the good of all. The U.S. has had some stunning technological success in undertakings that required cooperation between numbers of organizations and agencies and a sympathetic, non-interventionist, but supportive government. The space program under NASA is perhaps the most dramatic example. Success in basic research and applied technology was achieved via rationalization of the problem into parts and the provision of a strong information infrastructure that enabled all the people and companies working on various problems to communicate and work together freely. This horizontal dissemination of information avoided costly duplication of effort and delays that often plague technical researchers obsessed with guarding trade secrets or fearful of possible violation of antitrust laws. Technology, whether it takes the form of electronics, bioengineering, or any of a number of other newly emerging industries, has changed all the traditional rules of product development and competition in the international marketplace. Unlike traditional industries from whose environment the U.S. has drawn its current trade, regulatory, and tax policies, high-tech industries advance at an unprecedentedly rapid rate. Shorter product development cycles, new investment requirements, and the active participation in the competitive struggle for worldwide technological dominance by foreign governments all point to the need for new policies. If these policies are merely reactionary, they will fail. Protectionism can't protect high tech. America's technology policies will be effective only if they are based on a clear understanding of these new realities we're addressing throughout the course of this conference. Thank you.
Now we do have time for questions. If you have a question, would you please stand where you are and shout it out? I think that will be more efficient than trying to write them down. And I guess we could take questions to either of the first two speakers. Yes?
You suggested that technology should be available to all users, that foundation should not dominate. That would tend to fly in the face of the patent principle. Would you, if new technology developed, would you hope it to be manufactured to the developer for the first several years?
The question was that sharing technology seems to fly in the face of the patent process and also those who invested in it. I think we need to understand that there are differences, I think, between applied technology and basic research, and I really reflect my comments more to the basic research parts of sharing, and that those who invest in applied technology should have the full benefit of patent and copyright protection.
Any other questions for either of our first two speakers this morning? Maybe there weren't 20 questions out there waiting to be. All right. Yes, there's a question.
Have you thought that the time frame would you think the mainland Chinese might have that is right?
Frankly, no. The question was, when will the mainland Chinese be a significant competitive threat? I don't have a good judgment on that myself. Although I do have strong awareness that Southeast Asian countries in general have very aggressive educational, training, industrial development, technology development goals. Visiting Singapore, Taiwan, Hong Kong, those countries are substantially ahead of the U.S. They're substantially smaller, of course, but substantially ahead of the U.S. in their focus on training engineers, especially in the computer industries.
Yes.
I believe that you suggested that the Japanese are having great success in targeting support of specific type technology to the disadvantage of the United States. You patently asserted that the U.S. government would attempt to do the same thing would be possible because of the rapid expulsion of high technology. Can you explain how you know that?
Good question. The question was, Japan is having success with targeting and government support, and why won't that work in the U.S.? I think targeting and government support work best when you're trying to catch up. And they do not work very well when you're in the lead. For one thing, the goals are much clearer when you're trying to catch up. When you're in the lead, it's not exactly clear where you're going to go, and that's one of the very fundamental difficulties, I think, of advanced technology planning.
Yesterday, Dr. DeLauer talked about a number of the projects which he believes are important for the national good. One of them was a project called VISIC. Now, VISIC is a project to try to extend the state-of-the-art in high-performance semiconductor technology. In particular, it's aimed at requirements for the Department of Defense. But that kind of a project, which intends and tries to do in a comprehensive fashion an extension of the state-of-the-art, which requires both science, technology, and engineering, or all factors of science, technology, and engineering, I think can be an important part of a nation's desire to extend its capabilities in certain areas. So I personally would disagree with the idea that you can't target. I think it's very hard to target industries. I think it's possible to select areas of technology where you can bet your life the future is going to be determined by those who can master the complete technologies. And mastery of the complete technologies is a mastery of science, technology, and engineering across the board. To give you a further example, there's a great deal of effort going on today in the universities in semiconductor design by any kind of title. There is next to nothing going on in universities in any way which addresses one of the fundamental issues of whether or not those semiconductor designs are going to be worth anything in a system. And that is the whole issue of packaging science and material science for packaging semiconductors, to cool them, to distribute power in them, and to make the whole thing work. Now, I think it's important and can be done to pick out certain areas of technology which are going to have a broad enough impact on the whole nation and decide that we're going to try to make sure, not with government direction necessarily, but with the joint efforts between industry, university, and perhaps government, to try to make sure that we have a comprehensive program to be leaders in those technologies.
We have time for one more.
Dr. Anderson, on Tuesday, Dr. Director Bob Cooper suggested that if somehow IBM hadn't chosen not to spend R&D dollars on supercomputers, we wouldn't be worrying about the Japanese today. And he seemed to imply also that if IBM would only somehow get back into supercomputers, we'd have nothing to worry about. How would you react to that?
Well, I've had a long history of if only IBM would do this, that, or the other thing. And it's a fairly common plaint. I suppose it reflects the fact that we're held in high esteem. I think this issue of supercomputers needs quite a bit of definition. I have personally very, very high respect for Fujitsu and Hitachi as competitors in the computer field. I also believe that when you talk about high-performance machines, you got to talk about whether you're talking about general-purpose machines or whether you're talking about general-purpose machines with processor features that do special things. In addition, you have to understand whether you're talking about highly parallel structures or special kinds of structures which have yet to be demonstrated as general purpose machines for the broad class of problems. I don't intend to respond by saying what's in IBM development programs, but I can assure you we're looking at all those aspects and have high regard for our competitors.
Thank you. Our third speaker is Fredrick W. Gary, Vice President of Corporate Engineering and Manufacturing for the General Electric Company. Fred Gary has a bachelor's degree from the Rose-Hulman University Institute of Technology and was awarded an honorary doctorate of engineering in 1968. He has held the positions of Vice President, Aircraft Engine Technical Division at GE, Vice President, Military Engine Division at GE, and Vice President, Technical Plans at GE. In 1974, he became President of Rohr Industries, and in 75 was elected to the post of Chief Executive Officer and finally Chairman of the Board. In 1980, he returned to GE as General Manager of the Aircraft Programs Department, has been Vice President of Corporate Engineering, and as I say, now is Vice President of Corporate Engineering and Manufacturing. Dr. Gary is member of the National Academy of Engineering. He serves on the advisory boards of several academic institutions in the United States. It's a great pleasure for me to introduce him. He will speak about export policy and technology transfer.
I got this subject because it's obvious that a mechanical engineer should talk about the fourth generation computer. As Mr. Savior in particular has emphasized today, today's economic, political, and military tensions and the role of high technology in each of these areas has accentuated the debate on U.S. trade issues and the proper and manageable regulatory mechanisms that must be employed to assure United States security on one hand and international competitiveness on the other. Thus, my subject today at a technical conference. I don't normally quote a Soviet minister in a plea for reason, but Nikita Khrushchev said something once about U.S.-Soviet trade relations that characterizes the dilemma we've gotten ourselves into lately over attempts to block technology leaks to the Soviet bloc of nations. In a sarcastic reference to our trade policy, he once suggested that the United States ought to embargo buttons because they hold up the pants of Russian soldiers. Now, normally I have quotations from our corporate chairman rather than a Soviet chairman on my office wall, but Mr. Khrushchev's analogy gets to the heart of the debate over regulatory controls on technology transfer. Since the 1982 CIA report on Soviet acquisition of Western technology, which was recently punctuated by the uncovered plot in Western Europe to smuggle a VAX computer system into the Soviet Union, our government has initiated a series of dramatic steps to turn back the tide of sensitive high-technology know-how flowing to the East Bloc. The Department of Defense has produced a secret list of so-called military critical technologies that's thicker than the Sears Roebuck catalog at Christmas time, and to put in good use, the Department of Commerce has proposed enough regulatory red tape to permanently clog up the U.S. export pipeline and smother our R&D activities. These overzealous proposals are a reaction to what indeed is a massive technological hemorrhage. Last summer, in a highly publicized incident, British authorities uncovered a smuggling ring responsible for the sale to Bulgaria of 2 banned computers that had substantial military and nuclear applications. The equipment was originally purchased by a company in Minneapolis, shipped to Cologne, then to England, and finally re-exported to Bulgaria. Then there was the West German, who set up a series of companies in Southern California to buy sophisticated technology from U.S. manufacturers. The equipment was shipped under false certification to a country in West Europe, eventually forwarded to Moscow by way of either neutral Switzerland or Austria. Before the scheme was exposed, the Soviets had bought everything necessary for a semiconductor manufacturing plant. And there are cases where Soviets have saved resources and years of research and development. Reconnaissance photos show marked similarities between the U.S. Minuteman silo and the Soviet SS-13 silos. Moscow's early warning and control aircraft, the Tu-126, shares remarkable design features with the U.S. AWACS airplane. Boeing's YC-14 cargo plane, which resulted from years of Boeing research and built after major breakthroughs in aerodynamic design, took off 16 months later in the Soviet Union as the AH-72. These examples tell why a new kind of technological Cold War has heated up in Washington. How to stop the Russians from harvesting Western know-how. No doubt about it, this is a very serious threat, but we must be careful not to be trapped into overreaction that will destroy the ability of U.S. high-technology industries to compete in world markets. Technological competitiveness is critical to U.S. economic vitality and in the long run to our national security. I want to commend the IEEE for calling attention to this situation in the February issue of IEEE Spectrum, which contains an excellent review article by Carol Truxall, which I invite you to read if you haven't read it already. The problem with restricting technology transfer today, as you know, is that just about all of our high technologies have some dual-use application for both commercial and military purposes. And just to make the problem more difficult, state-of-the-art commercial applications have moved ahead of the technologies in some fielded weapons systems. The CIA reports that the Soviets use every means from open literature to outright theft to obtain these technologies. And it's really quite easy. Trade shows, sales meetings, technical and scientific journals, university exchange programs, and a whole range of routine commercial transactions. But 70% is through illegal channels, blatant espionage, dummy corporations, blackmail, smuggling plots, and industrial spies. While all of this conjures up images of TV spy movies, it does pose a serious threat to the essential routine interaction of scientists, engineers, and manufacturers on whom we depend to keep our technological and competitive edge. As I just mentioned, 70% of Soviet acquisitions are illegal. But what about the other 30%? Closing off that 30% would mean serious damage to the open communication, which is essential to the rapid rate of knowledge generation by scientists and engineers in academia and industry of the free world. But that's happening already. And the irony of this is that one of our greatest strengths and a key to innovation, which is this open flow of information, is potentially one of our greatest vulnerabilities. But in the heat of protecting our technology, we must be careful not to let the Russians steal our whole way of life. How to plug this massive leak of technologies is a dilemma with no easy solution. How do we restrict Soviet access to our technology without being counterproductive to trade? In the rate of science and technology development, in our own access to foreign technology, and in our ability to use and employ the large number of scientists and engineers that are coming out of our universities, but who are foreign-born or foreign nationals. As a first step toward restricting Soviet access to Western technology, Congress directed the Department of Defense to draw up a list of military critical technologies to guide the Commerce Department for use in administering export controls. DoD came up with a 700-page secret catalog that covers virtually all industrial technology. This ostensibly is the technology that underlies the 100,000 odd commodity listings that Commerce already controls. Commerce already requires advanced approval before any unpublished technology can be released to East Bloc countries. With its new proposals, permission would be needed for any of this so-called military critical technology to be released to any foreign person, even our own allies. We're not tightening up on East-West trade. It's interactions with our own friends and allies that we're talking about. Let's examine for a moment what this would mean. For export to allied countries and Japan alone, U.S. industry goes to Commerce Department for permission 24,000 times a year and encounters typical delays of 1 month. So, the payoff for 720,000 days of delay is that Commerce screens out about 50 questionable transactions from the 24,000. The cost benefit here is somewhat doubtful, but what would it cost to expand such advanced approval requirements to technical data flows? Remember that the vast majority of U.S. high-tech exports is to our allies in Japan. If we expand approval requirements to the proposed non-selective list of technical data, interactions coming under control would then number in hundreds of thousands, which would mean delay in transactions that could put us out of competition and out of contact with the technology in the free world. How is it possible that in the midst of an otherwise successful campaign against repressive bureaucracy and big government, we're moving to smother our sunrise industries with a dead hand of regulation? Now, here's what's at stake. In the past decade, U.S. exports grew to a point that 1 out of every 6 jobs is now export-related. And even though that it's only 13% of the total manufacturer's output in the United States, high-tech industry accounts for 44% of our manufacturer's exports. Moreover, the high-tech sector generates over 2/3 of all defense-related hardware purchases. The point is that if we unilaterally restrict our high-tech sector, nothing is gained. We lose markets, we lose advancements in high technology, and we can be sure that our competitors will move into these free world markets as fast as they can. For example, half of General Electric's strongest competitors in international technological competition are foreign-based multinationals. There's virtually no field of important technology in which one or more of these foreign firms is not a strong competitor. In the General Electric of the past, Westinghouse used to be our primary sparring partner, but that's no longer the case. There's Siemens and Bayer and Philips and ASEA and Schlumberger and Fanuc and Brown Boveri, Toshiba, Hitachi, Fujitsu, and Mitsubishi, just to name a few. While some of us believe that the United States is still technologically superior across the board, other countries are selling roughly 3/4 of all high technology products in free world markets. And the United States thinks enough of foreign-produced high-tech products to import roughly $35 billion worth a year. Like it or not, we're involved in scores of fast-moving worldwide technology areas and races, and we can't sit on the sidelines just for fear of technology leaks. Now, no U.S. company wants to see its sophisticated technology used to support the weapon systems of our enemies. And I think the business community has a responsibility, and we're moving in this direction, to help generate a process that will slow Soviet acquisition of military critical technology to a minimum. First, let's look at what we have to work with. Well, we already have a multilateral agreement known as COCOM for export controls with our NATO allies and Japan. This gentleman's agreement is a joint effort to prevent strategic and sensitive commodities from getting into the hands of the Soviet bloc. And it works. In fact, the VAX computer was stopped with the help of COCOM member, which is West Germany. Now, there's a strong consensus of the need to strengthen COCOM, but we need to get COCOM nation agreement on extending controls to military critical technologies before we can expect effectively to limit such transfers to the Soviets. We also need to bring our other trading partners into similar cooperative agreement as their technological sophistication grows. Second, we must work together to identify those technologies that are truly military critical, separate from those that simply have military utility. A truly critical military technology is one that could actually create a near-term shift in the balance of power, a weapon system that would force us to develop a response or a countermeasure that would offset the value of any one of our important weapon systems. Maybe what we should call it is our supercritical technology. In any case, I believe our COCOM friends would cooperate with us if we limit our most severe restrictions in West-West trade to such areas. Technologies which are merely military utile should require no more than a restricted general license for transactions among COCOM allies and proven reliable consignees. Third, we need to recognize that all military important technology is not controllable. If a military function can be performed in an essentially equivalent way by a product that already is beyond our control, we only lose by slamming the barn door behind it. Either negotiate control agreements with other nations or resist the temptation to unilaterally control and damage the competitiveness of U.S. industry. Fourth, we need a policy that is flexible, one that adjusts controls to match the various risk levels of technology transfer mechanisms. Strict controls of things like turnkey plants and co-ventures are warranted, not for high-volume, routine transfers of sale data, commercial publications, and fundamental research communications. Fifth, I believe we can collaborate with defense to find creative ways to design products that reduce the need for export controls. Given an unclassified military critical technology list, civilian industry engineers might be able to design around some of the military critical technology in some of their products. In addition, we may be able to invent ways of making our products difficult to reverse engineer. Finally, we need to reduce the unreasonable delays in processing license applications. Cutting out unnecessary licensing is critical, and there is no excuse for not making use of modern information handling and telecommunications technology to improve the efficiency of the licensing process. Let me reiterate, we have before us a move to clamp down on research and high technology transactions with allied and friendly nations to an extent that could seriously damage U.S. competitiveness. The move is perhaps an overreaction to a real problem, but we can slow down Soviet access if we're reasonable on what technology must be restricted. The diffusion of leading-edge technologies among our major trading partners is extensive, but these nations have, in fact, demonstrated a willingness to